Good afternoon, everyone, and thank you for tuning in today. My name is Kelly Scott. I'm coordinating the Farm Robotics Challenge this year on behalf of UC Ag and Natural Resources. And it's my pleasure to welcome you to the third year of this competition and really appreciate your participation and jumping on this meeting to learn more about the challenge. So, oops. Moving forward, I just wanted to give you an overview of our kind of dense info pack session that we have planned for you today. So today's webinar, expect to learn more about the teams that are competing this year. We're going to go through instructions on how to put together your project proposals. There is a section on equipment for your projects that could help your robot move and perform functions. Our friends at LINAC are going to explain their program there. And then we're going to go over announcements of our top prizes this year, which is always exciting. And then at the end, we really do hope to have a few minutes so we can have some direct Q&A with you all to answer any questions that may come up during the presentation. But as we're going along, if you want to enter questions in the chat, my colleague Lucy here is on that, making sure that we're answering your questions and getting you all the info that you need. So here's where we're at. As of yesterday, when I pulled this information, we had 41 teams from all over the world that have registered to compete in this competition. And looking at the map, it spans all the way from the far left-hand side of University of Hawaii, Manoa, across the globe to Seoul National University in South Korea. So for comparison, last year we had 13 teams. So this is quite an expansion in the field of competitors. And here is the list. So last year also, we were able to flash everybody's logo up on the screen, and just with the amount of teams that are participating last year, we couldn't do that. So this is just the list of the teams. If you're on the call and you don't see your name on there, let us know, and we'll make sure that we add you in the back end. But this is also posted up on our website for you to check out. And it's in the results tab, which may not be completely intuitive, but I've created a subcategory for 2025, and that's where we're listing all the registered teams. So just so you know, there's a lot of great information on our website. If you haven't spent time kind of navigating through and watching some of the videos, I definitely highly encourage that. One other thing to note here is that we're aware that there are some schools that are fielding multiple teams, which we definitely encourage so long as each team is working on a unique project and has linked up with the support of an advisor, which can be a faculty member, a school staff member, or a grad student, and then as well as you have access to equipment. So as we get through the competition and we learn more about the team names, we'll delineate that on the website as well. So for instance, I know UC Davis has reached out, and I think there's 2 to 3 teams that want to compete just from that one university. But all that information will be updated as we go along in the process here. So what we wanted to take time today on primarily is making sure you have information on the first deliverable of the competition, which is our project proposal. And in a nutshell, it's what are you doing with your project? So the nature of this competition is largely self-guided, and the expectation is that you're completing your work at your pace and your own schedule, because we know this is on top of all your other responsibilities that you have going. However, we feel it's important as a competition. We want to keep you moving forward and on track, and give you the highest likelihood of completing a successful project. So we have 2 competition due dates for required deliverables. And this first one for the proposal guide is approaching in 3 weeks. And we feel you should be using this initial time to formulate your ideas and have that project really pretty much defined by the due date on February 6th. So over these next few slides, we're going to run through this whole thing for you. Note that in your project proposal, it's a high-level overview. It's not going to be scored. So we don't want you to put a ton of extra work and detail into this, to go for the A+. It's not going to yield you a bonus points. So there's no need for really detailed drawings and pictures and references and a 10 to 12 page submission. So less is more here. Keep it simple. But that being said, it's also not something to throw together at the last second, because information here should be the foundation and the structure for your project. And taking the time to clearly define and understand the problem that you're pursuing will result in a real focused and meaningful effort. So it's funny. Please put your name on the paper. That's the first thing. Like, you would be surprised. We do get some submissions without the team name, the institution. So very simple. Follow this guide and you'll be in perfect shape. Who are you? And then select which competition category that you want to compete in. Is it the air category for drones, or is it the land and Amiga? If you're doing a combined project, which I've heard some schools are doing, using both technologies, then mark both boxes. And then please designate your primary point of contact. Usually this will be the team advisor, which again is a faculty member, a grad student, or a school staff member, somebody that's really going to be responsible for the team and kind of the go-to person. And then as the applications were coming through online, I sent each of you a link to a Google Doc for your team roster. So please fill that out with all the team member information. And there's 2 tabs on that document. There's one for advisors, and then there's one for student team members. So make sure you pay attention to that. And if you don't have that link, I'm going to follow up with all the teams that have registered after this call. And again, send them the link. Send you this document so that you have it, as well as a link to the recording. We just want you to have all the information at your fingertips, so don't worry about that. So let's see. Diving into kind of more of the meat of what we're seeking here. Key and foundational part of this competition is using technology to help solve problems for farmers. So in order to produce a solution that meets the need of the farmer, they need to be engaged and involved in the development process. They will provide critical insight in helping to define the problem that you are seeking to solve. So we have 2 examples down here below. The first is Bob. He runs a farm. He's keenly aware of the day-to-day challenges he faces and how these affect his bottom line. He has, let's say, a farm that's 8 miles away from a campus and is willing to offer a small plot for field testing. So he's going to be a great asset to your project. And then next is Cassandra. In her position as a farm advisor, she supports many farms in her county that she works with. And let's say she's been working with these growers for 20 plus years. She understands the most pressing issues in her locale and territory. And she herself has been conducting field trials and research experiments for many years. So these are made up characters, but they're the type of people that we're encouraging you to reach out to for feedback on the problem and solution that you're bringing to them. So and the next one's not required, but we did see last year a good amount of teams had some outside, perhaps industry contact that they were working with for technical guidance and support on a part of their project. And so this one, we listed Amir as being a director of engineering with a specialty in vision systems. So he was helping with that aspect in terms of guiding the team. So that's we're calling it the Ag Partner Overview section. So make sure you have, as we listed above, at least one person that fits that role for you. So getting into this portion, section 3, your problem statement. So problem statement is simply a written statement about the customer, the person that you're trying to solve their problem. It's expressed usually as a pain point, a need, an opportunity, and your problem statement should be written from the customer or end user's point of view. The goal is to help the reader understand the task that the customer is trying to complete or the problem that they're trying to solve. So this is a real example that we have listed here. This is from Texas A&M and North Carolina State's project last year. They were one of our winners. And the prize that they won was the Excellence in Sustainability Prize. So and we have the picture there on the left-hand side of the peanut with the cowboy hat because they were working with a farmer that had a 1,000-acre peanut farm. So there's the context. So I just want to read this so that you can all understand what I'm talking about. So as a farmer, I'm trying to categorize the weeds in my field according to the height and size so that I can apply appropriate post-emergent weed control method and dose. It's extremely difficult to do this by manual visual supervision, especially over 1,000 acres, right? And because of the large size of my field and the vast diversity of variation of the weed species and sizes, this makes me feel frustrated because I waste money on herbicides and I'm unable to select the appropriate control method due to misjudgments of weed height and growth stage. So that's the problem statement. We have this broken down for you in the chart to really just guide you through every step of the way in developing this statement. This is a reference for you to consult as you're drafting this text. So let's quickly run through, based on the previous example. The user was simply defined as a farmer, which I think you could probably add a little more detail there. Perhaps the size of the farm would be relevant. Is it organic? Is it conventional? So there's a couple tips there. The action that was needed was categorizing weed size in order to apply appropriate levels of herbicide for control. So it's weed control. The problem was the difficulty and inaccuracies in doing this by manual visual inspection. There's just too much land to gather that information in that manner. And the reason this is an issue is because, quote unquote, money is wasted, creating both economic and operational inefficiencies. And the emotion is frustration, right? Which probably could be the emotion for almost every single problem that we're facing. But that's just a really clear, simple example. So as you're working through things, feel free to reference this document to help you with that piece of things. This next section moves into your solution. It's not focused on the problem. So first off, please provide us your elevator pitch for your project. So elevator pitch, for those of you that don't know, it's usually what you would say to somebody if you have 10 seconds to tell them what you do and what you're all about. Yeah, it's usually very brief, 1 or 2 sentences. So we really want you to truncate this down to the meat of what you're doing for your solution. So I like this example, and it's from Cal Poly from last year. And theirs is, our autonomous lettuce harvester reduces labor reliance, lowers costs, and improve harvesting efficiency through automation, enabling smaller farms to become more competitive. So, just in that sense alone, it really gives you a lot of information on what they're doing. Let's see here. And then the next part is really getting more into the meat of your design plan and your project. And we've listed some guiding questions below for you to consider, but you can extrapolate on this. Again, text is fine here. You don't need to provide a lot of detailed drawings at this point. And I can't remember if I mentioned it or not, but this part is due February 6th. I think it was listed on there, but I just wanted to be explicit and mention that again. So the last part that we're looking for is just choosing 3 metrics to evaluate your performance. So thinking about the previous example, one of the metrics that was chosen for that project was accuracy of height estimation of the plant canopy. It's one of the things that they wanted to measure. This was important because it informs a farmer's choice of weed control methods and application rates. And this would be, how would this be calculated? It would be point cloud or depth map generated from stereo images compared to the LiDAR sensor that they had on the robot. So they got into the details of exactly what they were measuring and how they were going to do it. The last point is, well, how much information should we gather in order to have a meaningful result? So that is the gist of the project plan and proposal. Just checking in with Lucy here to see if there's any questions in the chat about this particular part of the presentation I could address right now, or we could just kind of move on forward.
Seems like we're good to move on. If anybody has a question they want to verbally ask, feel free to
or maybe just raise your hand so you can see who's doing it. Yeah, okay. So while we're waiting on that, the project plan proposal is on the website. So we're really doing our best to hang all the documents that you need on the website in the resources section, so you can download it directly from there, so that you have it at your fingertips when you need it. So in the same vein of thinking about working with ag partners to understand the problems and challenges that are faced in farming, we have planned a separate webinar next Tuesday. This is going to be hosted with our friends at the Farm Foundation, who are organizing a group of farmers to talk about just that. And they're bringing together folks all over the United States to talk about their unique issues that they have in their farm. We're going to have several different types of farms. So I think this is going to be a really good informational session for you to tune into if you can live, but we're also going to record it and post it on the website and send it out to the teams just to kind of understand what's going on in the industry. It's such a big part of this competition. So we want to try and provide you all the opportunities to learn about those things that you can. So thanks to the Farm Foundation for organizing this. And we are going to send out follow-up information via email shortly, so that you'll have that on information in how to tune in and watch that webinar. So looks like I'm right on track in terms of our timeline that we set for this presentation. I'm going to ask this next section, we're going to have guest presenter from LINAC. And is Andrew McGinnis on the call? He's an applications engineer.
I am. Can you hear me here?
Yeah.
And
so Andrew,
this is
and Jordan.
This is Jordan's here too. Yeah, I was going to do just a quick introduction about the company, and then Andrew was going to do a more in-depth discussion about our products and what we can offer the teams.
Wonderful, Jordan. I'm going to stop sharing my screen then. Here.
Okay, I was going to ask
you'll
if I
have
could
to
share
make
my
Jordan
screen.
and USAMC co-hosts.
Okay, I'll go and do that right now.
Thank you.
Oh, there she is. Okay. Here you go, Jordan. You are co-host. And Andrew as well. So first off, thank you both for joining the meeting today. Really happy to have you on board and looking forward to learning about this program.
Okay, can you guys see my screen?
Yes.
Hate to be the old person to ask that, but we don't use Zoom a lot, so it's a challenge for us. Okay, so thank you, Kelly, for the introduction. My name is Jordan Embley. I am the marketing specialist at LINAC. Also on the call, you heard Andrew. He's our applications engineer. And then Casey Munch is on here as well. He is a sales engineer for LINAC. And we're new to the Farm Robotics Challenge. This is our first year being a sponsor. So we wanted to take the time to introduce ourselves, explain our product offering, and how we can help you all with your projects. So a little bit about Linac. We are a family-owned company. Our headquarters is in Denmark. The family has owned it since 1907. Our current owner took over the company in the 70s. And it was at that time that he made our first electric linear actuator. And since then, that's been the main focus of our company. It's grown substantially over the years. You can see from this map that we have sales offices and factories all over the world. So our North American headquarters is in Louisville, Kentucky. I'll get into that in the next slide, but that's where me and Andrew are from. And then Casey is our West Coast sales representative, so he's in California. But you can see on this slide that we have over 1,200 patents, 2,400 employees, over 12,000 customers. Most of those customers are in three major segments, which include industrial furniture, healthcare segments like hospital beds, and then what we call the industrial segments, which includes agriculture. We've worked with the major agriculture equipment manufacturers for decades, so we have lots of experience in this market. And we're thrilled to have the opportunity to work with you all in the future of this market. And we've done some other competitions like this. So we love being able to work with universities and kind of get in on the ground when these new applications are coming to life. But this, like I said, it's our first time being with Farm Robotics, so happy to be here. Okay, and a little bit about our office in Louisville, Kentucky. You can see from this picture, we have 3 buildings. So we are the only manufacturing site in North America. So hopefully most of the products that we have for you will be made in our Louisville, Kentucky facilities, but we do have actuators that come from Denmark as well. So on site, I mentioned manufacturing. We also have large warehouse facilities, and then we have engineers on staff, such as Andrew, that provide great resources for our customers, and then you all as well to help build all of our products custom for each application, which is a huge benefit for our customers. So with that, I will pass it over to Andrew, who will tell you all about electric linear actuators.
Everybody.
Andrew, I'm going to interrupt you for 1 second. I just wondered if you guys have the ability to turn your camera on. Can you do that? If not, it's okay.
I got my kids in the background, so I'm not going to do that.
You're good,
Andrew can.
I stuck around in the office. It's dark outside, but I didn't want to have the kids in the background throwing things. Yeah, so I guess before I jump into what is a linear actuator, I want to prime it a little bit with why are we presenting about linear actuators, and give a sneak preview to a few slides down. What we're hoping to do here is sponsor not just the event itself, not just write a check, but sponsor components that can help you guys with innovative agricultural equipment that you're developing. So we understand that that FarmNG has provided Amiga platforms, development platforms that the land-based teams are using. And so the idea here is we're expecting teams to be able to take our components and integrate them and build on the Amiga platforms and help to create some innovative designs. So we're a component that you can be building your equipment and essentially adding new features that wouldn't be possible without linear movement. So with that said, I'll jump into an overview. What is an electric linear actuator and what would you do with it? Electric actuator is essentially linear movement. It's going to push or pull some kind of load. When it's powered down, it will hold that load. And it is, just to describe it most simply, it's an electric DC motor that turns a gearbox, that turns a screw, that pushes a nut and drives the load in or out. It's used in thousands of different ag applications, but you could think about it, the best analogy is applications that historically have been a hydraulic cylinder for in and out control, but that are now moving to electrified machinery and want more precise control. So this is a package that you could take out a hydraulic cylinder, put an electric actuator in, and get more fine-tuned control, and you're removing your hydraulic hoses, your hydraulic pumps, and replacing it with a purely electric component. Why would you want to use an electric actuator? Like I just mentioned, you get precise control. So the John Deeres, the Cases of the world are using 8 to 10 linear actuators per combine for all sorts of precise adjustment that they can automate from the CAN ECUs that are driving their machinery, really driving precision, but then also automation and potential for autonomy in mobile ag equipment. We don't just support the big player OEMs, though. We also have hundreds of customers who are smaller, 10, 20, 50 machines a year, making specialty crop harvesting equipment, berry harvesters, things like that. So really, we support the full spectrum, and there are thousands of different applications for an actuator, and I expect these teams to come up with the few I haven't seen before. One of the main advantages of buying an actuator, or the actuators we're talking about today, in this case we're sponsoring, so not buying, but using an actuator we're sponsoring, you get an integrated H-bridge controller that handles a lot of the heavy lifting of controlling a motor, position sensing, speed control, overload protection. So you can essentially wire the actuator up to your power supply, connect it to your CAN, and send it messages telling it where to go. And the actuator package handles the rest of the heavy lifting there from an electrical design and software design standpoint. The other advantage to an electric actuator, it's very efficient from a standby perspective. So it doesn't take power to continuously hold the load. It has an inherent self-lock. So if you have a feature that you're adjusting every once in a while, it's only drawing power when you're making that adjustment, and then the actuator continues to hold that load when you're not running. So for this, for the teams and for the sponsorship, since there's a pretty compressed schedule to this competition, we went ahead and created 3 flavors of actuators that we are pre-building for stock so that they're ready to ship out to teams. This presentation here has basic rundown of the specs of the 3 different versions. But just to give a scale of the smaller actuator here, this is what we're talking about. Handheld device, pushes 300 newtons of load, can move it 130 millimeters in and out, and is running on a 24-volt supply and connected up to, you can run this over your CAN network that's integrated into the Amiga. You could also run this over just run in and out signal wires. So you don't necessarily have to be doing CAN integration on this. That's the option on the left, the LA14. The option on the right is a much bigger actuator. Show an example here on the camera here. It's about 3 times the size and much higher load. So we've got a 4,500 Newton load rating in the option A, and option B is a 6,800 Newton. You'll see we essentially have a longer stroke length, faster, lower load version in option A, and a shorter stroke length, higher force version in option B. These 2 options on the right, the LA36 models, will actually connect up to the Amiga's 44-volt system. So my understanding is that the main battery supply is a 44-volt supply. So in this case, these can be supplied directly from that power bus. The LA14 model, we don't actually make that in a 48-volt version. So there will be some step down to 24-volt required in order to run that option. And I did see a question in the chat asking about speeds of these 2 options. So rather than get into too many details there, I'll say that we have full data sheets on each of these 3 actuators that we have that are available that give you mechanical dimensions, they give you speeds, they give you loads, current draw, the full gamut of specs that you need there. But in general, we're talking for these versions of actuators, we're talking about moving in the ballpark of a half an inch a second.
And I gave those data sheets to you, Kelly, to share with the teams.
Yes. Is that okay if we put those up on our website in the resources section and teams can download them? Okay.
Yeah,
Absolutely.
Then that's
absolutely.
what we'll do.
Mhm.
Okay.
Yep.
Perfect.
So each of these three options of actuators, you can connect directly to the CAN network or run over manual run switch wires. So there's a common interface, and next slide just gives some information on that. Running one of our actuators, connecting it to the CAN network is as simple as powering the brown and blue wires. Those are a fixed DC power. So in the case of the smaller actuator, you'll apply 24 volts and ground. In the case of the larger actuators, you'll apply the 44 volt in ground there. You can run the actuator in and out just by pulling the red wire or black wire. We call those manual run. Pulling that to the supply voltage. So that's not a 5-volt signal, that's a full supply voltage signal, but then that sends a message to the H bridge to run in and out. That's the simplest way to run the actuator in and out, but you don't get position feedback, you don't get error messages if it hits an obstruction or something like that. The recommended implementation would be to connect the yellow and green wires to your CAN network. That way your ECU can send run in, run out, speed control, current control messages, and it can get back position feedback and if there's an error like an overload, it can get back those status messages. So there is an entire probably 60-page CAN manual. We're not going to go over that in this presentation, but that's a part of the package that Jordan mentioned earlier. So that should be loaded onto the website. And that gets into messaging structure and details like that. But if you are using an actuator in your design, happy to support any questions that come up with how do I integrate this, help me understand the user manual. Hey, I have an actuator and it's not moving. Help me troubleshoot these first steps to get the system moving. So please feel free to reach out to me for that sort of support. And as far as samples that we have available, so we have a package for these three actuators, step files for 3D models, the CAN bus resources you need to control, actuator specific data sheets, and each actuator will ship with a configuration cable that lets you get it running just with a USB program for the first few steps of developing your mechanics. And available for this sponsorship, we have built 10 of each of the LA36 models, and those are built now, ready to ship. And the LA14, we have a handful of those. Those are built in our factory in Denmark. Those will be here in about 2 weeks, so those will follow shortly. They're available on a first come, first served basis. Since this is our first time sponsoring the event, we weren't sure, there's 30 some teams, weren't sure how many teams would actually be using this in their design. So we've built a decent bit of stock. Please reach out if you have a project. And I guess I would ask that you send a paragraph of, hey, here's our project, here's how we'd like to use a linear actuator, and can you ship us this sample of the 3 different options? Due to the logistic constraints, this year we are limiting the samples to teams in North America, just with the time scale of the competition. We didn't think we could be shipping parts to South Korea in a timely manner. If you are overseas and you're interested, please reach out to us and we'll see what we can do, but it's tough for us to guarantee that we can get you an actuator in reasonable time for the competition. A handful of examples, and then that'll be it for us today. that LA36, the larger model I mentioned, were used on all flagship combines. This is an example of about the biggest application you would see in an electric actuator. So this is a grain spout on the unloading tube from a combine. So when you're unloading grain from combine into a grain cart, this spout boot can extend and retract to more evenly fill the grain cart as it's unloading. It's about the biggest application. Some smaller applications, the LA14. This is an example of a spreader application where the actuator is controlling some diverters to so that the pattern that the spinner spreader spreads granulate over a field. It's adjusting that pattern to widen or narrow the pattern. So these are a couple of examples. This is another picture of a similar example, just to give you some ideas about how actuators can be mounted and used. I think that's it. Please reach out if you have interest in a sample for your team, and we're happy to sponsor it. And any questions from a technical standpoint, my contact is in the bottom left here on this presentation.
Just one point of clarification there, Andrew. I think maybe it's easy to have a single point of contact. Is that okay? So are you that person if a team would like one of the actuators donated to them?
Yes. Yep.
Okay.
Happy
Perfect.
to reach out. If I need to loop Casey in from a sales standpoint, just getting parts out the door, I'll add people from Linux as necessary.
Okay. Sounds good.
All right, and thank you for your time. I look forward to seeing all the projects that come out of this.
Wonderful. Thank you, Andrew, Casey, and Jordan. Really appreciate this opportunity, your support of the challenge, your support of the teams. I think it's going to be great. We will have this information sent out to all the teams. So if you weren't able to jot that down, you have it. This whole thing is being recorded. It'll be posted, and then I'll send out the slide deck as well. So you guys can have that. So looks like we're right on schedule, which is great. Rarely happens. But looking at our agenda, I think I'm going to kick it over to Marcelo at FarmNG.
Hello, everybody. Hey, Kelly. I want to share my screen real quick, so I guess you need to let me. There you go. All right, you might be seeing our first page here. So I think I've met some of the teams already and some of the people working at the Farm Robotics Challenge, at least in the land competition. But a quick intro: I'm Marcelo Queiroz. I'm the lead support here at FarmNG, and I'll be your point of contact. I'd like to start thanking you on behalf of FarmNG and also on behalf of your future selves. Back in my college days, I actually worked on college competitions, and I think it's a very great way to see how how's the world out there, how business are made, and we've seen in the last couple of robotics challenge, we've seen a very great level of technical and organizational projects. Really putting large teams like this together is not easy, and I can tell by the amount of teams, and it feels like we're one level up here this year. So really thank you. Then I'll go through today. I'm gonna talk through the resources available for you working with the Amigas on this challenge. Probably, I don't know how familiar you are with the Amiga, but on a glimpse, the Amiga is this affordable, flexible, simple robotics platform for agriculture. So it's rugged. We leave ours outside all the time. It can handle water. It can handle the environment of a farm. And the idea is that we build something that create layers of abstractions, so you don't have to deal with all the difficult part of robotics. So I wouldn't be a support person if I didn't start with a read the docs page, um, diving into what we have available for you for the teams. I think this is the focal point of our product, right? So when you come to amiga.farmng.com, you get access to all of our documentations. This is open for everyone, even if you don't have a machine yet. And I want to ask you, I really encourage you guys to read through the user manual of the Amiga. This gives you a really good idea on how the platform is assembled, nomenclature, so we can talk in one language, even things like how the CAN bus runs. So when you connect your Linux actuator, you know where to connect and how they talk, right? The second thing I would say, I'm assuming most of the teams will work with software. There is a whole section on how the foundational software on our operational system works. So you guys can start getting the pieces of software that we make open source for you guys, connect these pieces and make the robot do things, right? And then finally, we got examples that tells you, oh, how do I look at the camera? How do I see the point cloud of this? Maybe how do I make the robot drive a square or drive a track? So all of these are examples that are on our open source SDK, or ADK as we like to call it, the Amiga Development Kit. In so this is the very first point of contact. The second part I want to point you to is the discourse forum. So you can access here or at discourse.farmng.com. So this forum is basically where you can ask questions and interact with your peers. I check this twice a day. So you see that I answer a lot of questions here, but we encourage people to share knowledge here and to get together. This is really a great source. And then finally, we will start hosting what we call our office hours, right? So we will start sending out the dates for these, but basically these will be times then when the teams can come, and this will be open for all teams, and we can share ideas. I think a lot of the times on the office hours, you can get new ideas. You can get even listening to other people's problems. You can understand. You can figure out your problems as well. So very important resource there. I would encourage you guys to send your questions in advance to our email, support@farmng.com, and of course, so I can prepare in advance and we can make the most out of that time. So basically these three resources that I mentioned, right? The documentation, the discourse, and the office hours. These are open for everyone, and these are we have no restrictions on that, and which means so you can post as many questions as you want, and I'll do my best to follow up on everything. Then we also have, if you have questions that you want like not to be public, you can also reach out to me either at Marcelo 1L at farmng.com or support@farmng.com. And also you see that on my email signatures, there is a phone number. We can interact there. I would say we do have a support level agreement. I don't want to, go through, legalese at this point, but basically, we on that, I can to make sure that all teams have access to support and all of our customers. There will be, it may have some more time to answer. And finally, these support, I try to on these support channels, we stick to the parts, to pieces of hardware and software that are standard on the Amiga. So we make sure that we're, treating all teams on, the same, we're leveling the field there. And yes, so basically, I encourage, get to the public channels as much as possible, right? Finally, that's what I have for today. I want to, leave some, last remarks here, or I guess an piece of advice here from FarmNG side. Really, I encourage you guys to start early. Start testing your solutions, different pieces of software, and then you start putting them together. I'm pretty sure all of you know that the software part is hard, hardware is hard, and then when you start putting those two together in robotics, that is hard, and most importantly, farming is very difficult as well. So when you try to create the system engineering, right? When you try to put everything together, it's things start getting finicky. So start early, start testing everything, and reach out for support at FarmNG. And I'm looking forward to see what you guys will build. Thank you.
Great, thanks, Marcelo. Really have a lot of ways that folks can reach out to you and get in touch, which is great. At this point in time, I'm going to hand it over to Leanne Gluck, also at FarmNG, and I think she has the most exciting part of the presentation. So I hope Leanne is ready to go here with this. So she is going.
Share, Kelly.
There you go. She's going to talk about grand prize for this year.
Okay. Hi, everybody. My name is Leanne Gluck. I am with FarmNG, and I am so excited for this year's challenge and to see what all of you come up with. This year, FarmNG, along with Western Growers, is sponsoring the Innovation Award. The prize pot at this point is up to $20K. What we learned from last year was that there was a number of student teams that really did create projects that were almost pre-commercializable. The judges last year really told us that story, that there were some projects that really they saw as something that could really be taken to market. So we wanted to help to support students who were looking with an eye towards that this year, and really providing a little bit additional support for students and emerging innovators to translate your ideas into actionable and market-ready solutions. So the Innovation Award is $20K. We'll be looking at feasibility and functionality, that your idea is not just theoretical, but it's been tested to be in real world scenarios, that there's some scalability and commercial potential there, and that there's obviously innovation and originality. And along with that, what we're working on is that not only will we be providing dollars, which we're almost thinking of a little bit as pre-seed dollars, but we're also working with a number of different partners, including the Farm Foundation, Western Growers, a number of different test and farm incubator programs to really provide almost a mini accelerator experience to the winning teams, which includes things like connection to industry and investor community. So we invite the winning team to FIRA, and we're working on having what we're calling a day 4 at FIRA, where not only do you come to FIRA, but you also get to pitch your idea in front of industry and potential investors, working with a couple of different partners around mentorship opportunities, and also creating this opportunity potential for on-farm incubation for the winning team, if of interest, and potentially other teams as well, where you can take what you've built and then actually can continue to build it out on farm. So we're really excited and really want to support, taking this not just from idea, but actually continue to support how it moves from prototype into real world application. And we're here to support that. Thanks, Kelly.
Excellent. Thank you, Leanne. Now, this is exciting. I am going to continue the conversation on prizes. So just to kind of round out and summarize what Leanne was talking about, here's how we're doing the awards this year. We're offering cash prizes to winning teams in each category. And just to be clear, the $20,000 Innovation Award is for the land category using the Amiga robot. We are going to award travel stipends up to $5,000 for, at this point in time, the grand prize winning teams. So the top 2 teams in each category. And that is for what we were talking about is, if you haven't been before, FIRA is an ag tech conference just outside of Sacramento, California here. And this year we had 2,000 plus people, 30 plus awesome ag tech robotics companies. It's really kind of the ecosystem of innovation and ag tech. And the reason that we want to bring the winning teams here is because we want to bring you into the fold, into the industry, make those important connections for your career, whether it be to expand your research or potentially thinking about starting your own company, or perhaps job opportunities with current companies. So all those things are available at FIRA. It's really something that we'd love to bring all the team members and cohorts to, but we do have some restrictions on our resources there. But so that's the FIRA portion of it. Leanne also mentioned, we want to help you get to the next step. And whatever we can do in terms of our network and flexing that, making connections, that's really our goal. This is a relationship that we're building with you as the team members, and we want that to move forward. So we don't have all the details ready to print yet, but we just want to say that we're working on a couple different arrangements for this year. So going through, kind of rounding out the prizes that we've identified for this year. Leanne talked about the Innovation Award in the land category, $20,000. The grand prize for the air category, we're going to call it the Productivity Award, pretty similar. But it also includes a travel stipend of up to $5,000 to attend the FIRA conference. So the winner of this prize will produce a project that has demonstrated it's functional and highly effective solution to a farmer problem or challenge. The project is going to have strong economic value to the farmer, and it shows potential as a viable market-ready solution. So then we kind of have our subcategories under the grand prizes, and we haven't set dollar amounts for these yet. We're still working on it, but I will say, for the record, I'm shooting for these will be probably $5,000 prizes likely. And those categories are excellence in regenerative agriculture. This award will be presented to the team that best addresses environmental outcomes. And this solution is going to go beyond kind of just maintaining the status quo, presents a solution that helps to build a resilient ecosystem. Think about things like soil health and regeneration, biodiversity enhancement, water conservation, kind of thinking about the whole kind of holistic farm management category. So that's regenerative ag. And then small farms tech. So we want to incorporate small farmers, which are a huge portion of the farms in the United States. It gets close to 90%. But and a small farm, I looked this up today, is defined by USDA as a farm that produces $350,000 or less in gross cash farm income. So just so you have the definition of what that means. So it's going to be the team that best creates a solution for the small farmer. And then we want to give some flexibility to our judges to kind of award their picks for best in show. What stood out to them? So we're not necessarily defining that right now, but we're going to leave some flexibility to the judges to make those determinations. And just so you know, judging panel is a mix of folks. It's folks from industry, of course. It's folks from academia. And then this year, we're going to bring some folks on from the investment community. So it's a really well-rounded panel that's going to help us evaluate all the different projects. So that's it for the prizes and awards. And I want to give a shout out to our sponsors, because we wouldn't be able to offer prizes and awards if it weren't for them. So this is our current list of folks that are supporting us. So I'm going to rattle through them real quick because I want to make sure each one gets individual attention. F3, thank you. Of course, Farm and G and Western Growers, who are teaming up on the Innovation Award. Bex has been a supporter of this event from the beginning. We also have folks, good support from the California Tomato Research Institute, US Soy, which is the checkoff program. And then you heard from Linac on the call, who is a sponsor of the challenge, and then also providing in-kind product donation to teams. So thank you for making this all possible. It really makes this competition shine. So thank you again. And I've left 1 minute for Q&A, which was not the intention. But Lucy, I'm going to check in with you. Were there any questions in the chat that we did not address during the presentation that we can go through really quickly here?
Not that I'm seeing. I think we addressed all the questions, but everybody should have the ability to unmute themselves. And so if there's any last minute questions, feel free to drop them in the chat or just speak out. Yeah. It's great for you to ask them here because we are recording the meeting. And so if anybody watches this later, they can also benefit from hearing the answers to your questions.
I have a question. Okay,
sure.
Hello?
Hello? I think we have Gregory and Fangkai.
Yeah, I just wondering, is there any word limitation for the proposal?
Sorry, could you say that one more time? The audio is not super clear.
Oh, is there any word limitation about the proposal?
Oh, any word limitations? I don't know. We no word limitations.
I would say aim for 1 to 2 pages.
Yeah,
that should suffice.
Super long.
Yeah, I went through some of them in preparation for this meeting from last year. There are a couple that were 8+. That's not necessary at this point. We really just want to get the basic idea down and give you some feedback if it looks great, or if we have some questions, and we can kind of coach you along the way. That's all it's for, and to keep you on track to get moving on your projects. So thanks for that good question.
I have a question. Sorry, I came here about 7 minutes late while you were talking about the proposals. What are the upcoming due dates?
Yes, February 6th.
Cool. Thank you so much.
Yep.
And this whole meeting will be posted and shared, so you can always go back and look at the stuff you missed.